Hey there, math lovers. So today I decided to solve an algebraic equation of higher order for you guys as well. And the reason for that is a while ago, a user called Mulberry actually asked for it, and in the comment section, because I'd been solving many such equations of order 6, 5, 4, I don't remember, perhaps even 11, and he kind of liked it, and he asked me in the comment section if I could solve another such equation and dedicate it to him. And there you go. I was on holidays, so I didn't have time. Mulberry, this video is dedicated to you. And yeah, we have an equation of order 4. Just to give you a little bit background, guys, so we cannot solve an equation of order 5 and bigger. And it's been proved in algebra, but so we basically, whenever we are giving such an equation, we try to resort to some trick in order to solve these problems. And one of these tricks is to guess the roots. And I guess if you, and by the way, there are systematic ways to guess these roots. Maybe later I'll make a video on that, how to guess roots in a systematic way, because it can be completely blind, and that's just not the most efficient approach. But here, I don't want to make it complicated. If you just pay attention to the coefficients, you will find out that x equals -1 actually is a root, because that gives me 2 minus 7 minus 34 plus 21 plus 18, which is basically these two guys minus 41, and the other one's also 41, and that is 0. And by the way, you can then divide the whole expression by x plus 1, because that's a factor, and then you'll get an expression of order 3. And I guess there also you can further simplify it, perhaps by guessing another factor, and so on, and solve this problem. But today I would like to solve this problem using a completely new method, and that's the nice thing about it. Well, not completely new, because I have already made a video on reciprocal equations. And in reciprocal equations, basically, if we have, let's say, an equation of order 4, such as ax4 plus bx3 plus cx2 plus dx plus e equals 0, it happens that actually these coefficients are the same. So in other words, here instead of e I have a, and then here instead of d I have also b. So these coefficients are the same, and they correspond to basically those powers of x where when you basically sum their powers, you get the order of the equation. So here, this is basically x to the power of 0. So you see that 4 plus 0 equals 3 plus 1 here. So if you pay attention to these factors of such powers of x, then they are the same. And if this situation happens, then you say, well, we have a reciprocal equation. And if you have a reciprocal equation, it can be solved by dividing both sides of the equation by a factor such as x2, which is basically this guy, and then doing the change of variables. Here we don't have the same situation, because here we have 2 and here we have 18, and they are not the same. And obviously here we have 7 and here we have minus 21. They're absolutely not the same. However, do not get disappointed by this at all, because even though they are not the same, but still you can solve it using a very similar approach, and I will show you. So indulge with me for a second. So what I'm going to do is to basically divide both sides of this equation by x2, and I'll explain to you why this approach still is basically gonna work. So if I do that, then I have 2 times x2 let's look at the equation, and then we can actually put it next to 18. Then I get 2 times x2. Imagine that I have divided both sides by x2 plus 9 over x2, and that gives me the 18 factor. And then here I have plus 7 times x minus 21 over x. Sorry, this must be 3 because then 7 is factorized. Minus 34, this is equal to 0. So here, if I take x minus 3 over x to be some new variable such as t, this parenthesis here can be also written based on t. It's not difficult to prove this. So the trick here is that you see, well, if you factorize this term here with, and basically if you factorize 2, then you have x4 plus 9, and that 9, as a matter of fact, and also if you just take that in mind for a second, and if you here also factorize 7, then you have 7, and then here 7 times 3. So that 9 and these 3 are having a relationship with each other, and the relationship is that 9 is 3 to the power of 2. So just for you to know when you can use this approach, because this is not always possible, but this is completely a special case. So now let's go back to the problem and see how we can solve this problem. So if this is my change of variables, then x2 plus 9 over x2 will be, well, I can write this as x minus 3 over x to the power of 2, okay, plus 6. I hope you agree with me. You have to just expand this. It's not really difficult, and then that is nothing but t squared plus 6, which means if I go back to this equation here, then I get 2 times t2 plus 6 plus 7t minus 34 equals 0. What is this? This is nothing but a quadratic equation, which is very simple to solve, and then this gives me 2t squared plus 7t, and that is 12 minus 34, which is basically minus 22. This is equal to 0, if I'm not wrong. So then solving this equation will give, it gives me minus 7 plus minus square root of 49 plus 8 times 22, which is basically 176, if I'm not wrong, divided by 4. And that gives me 210, 15, 225, which is basically square root of it is 15. That gives me minus 7 plus minus 15 over 4, which is, if you take plus, that is 15 minus 7, 8 divided by 4, that is 2, and then minus 22 divided by 4, which is minus 11 divided by 2. Okay, and now let's go back to this equation here, which we had, the change of variables. So we have x minus 3 over x equals t. Let's just solve it for general t and just replace t, and then that gives me x2 minus t x minus 3 equals 0. Using the quadratic formula, x is t plus minus square root of t squared plus 12 divided by 2. So if you take t to be 2, then x will be 2 plus minus square root of, well, 4 plus 12, that is 16 divided by 2, that is 4. So the answers are basically 2 plus 4 divided by 2 is 3, and 2 minus 4 divided by 2 is minus 1. So those are two answers, and let's take the other one, t, to be minus 11 over 2, and then x will be minus 11 over 2 plus minus square root of, well, 11 over 2 to the power of 2, that is 121 over 4 plus 12 divided by 2. Okay, what is that then? That is 48. So let's say 121 plus 48, that is 169. And we know that this is 13 to the power of 2. So that is minus 11 over 2 plus minus 13 over 2 divided by 2. So the other two answers are, so 13 minus 11, that is 2. So if you take plus, and 2 divided by 2 is 1 over 2. So this is one answer. And if you take minus, that is minus 24 divided by 2, which is minus 12, and divided by 2, that is minus 6. So these will be the answers. And there you have it. I hope you enjoyed solving this problem with me, especially you, Mowberry. You requested it specifically for this problem. Not this problem, but a similar one. And maybe next time you send a equation to me, and I'll try my best to solve that problem. So till next time, keep exploring the fascinating world of mathematics.